All right. 4.2 talks about two different theorems. So you have Mr. Rolle's theorem, and then you have the mean value theorem. The Rolle's theorem doesn't show up that much, but it's really not that kind of difficult to understand. So it has to make sure that you fit all three of those hypotheses. Okay, so you have to make sure that it's continuous on the closed interval, differentiable on the open, and then you want to make sure that your endpoints are the same value. Okay, if this happens, what it says is that there's a value somewhere in between that open interval such that your derivative is equal to 0. Okay? I'm sorry? Means you can find the derivative between this number and that number. So, like, this is something that's continuous but not differentiable. Right, exactly. Okay. So this is saying that somewhere on your, if this happens, right, there's going to be a number in between the two such that you have a horizontal tangent, right? So if you know that the endpoints equal each other, right? Right, we have A, we have B. So if I know that if my equation kind of starts there, right, and it goes up, right, and we know that this is going to be true, right? So that means that this point has one over here as well, right? So if it originally goes up, right, but we know eventually it's going to come back down to this point here, it's got to do what eventually? If it's going to go up, it's going to eventually have to start to change direction and then go back down again. So somewhere it has to change direction and then go back down. So whenever it changes direction, which would be that point right there, that is where you have a horizontal tangent, right? And this is where your derivative would be 0. So there's got to be some point in between the two where you change direction and you start going down. Or if you had a decreasing function, there's got to be a point somewhere where you start going back up again to get that original value. All right? So you always want to test, make sure that your endpoints are the same value, and then you can figure out what's the value in between such that you have a horizontal tangent. So if you look at the first one, right, A and B are the same value. So really I could have infinite many values in between that give me a horizontal tangent. That's because it's a horizontal line. So that's kind of looks like the one that I just did. If you have the same value, right, if it goes up, it's got to come back down in order for it to be the same value. So right here, this is where you have a horizontal tangent. That's where your derivative is equal to 0. So you're going to be asked to kind of figure out what exactly is that value. All right, that one has 2. So you can have more than one case where it happens. Right. So if the endpoints are the same, what it's saying is that there's got to be somewhere in between the two where it kind of levels off like that and changes direction. Okay, so All right, so you have x to the fourth minus 2x squared from negative 2 to 2. Determine if Rolle's theorem applies. If so, find the value guaranteed by the theorem. Okay, so is that a continuous function? Right? It's polynomial. All polynomials are continuous. All polynomials are differentiable, right? So f is continuous and differentiable on negative 2 to 2. And then negative 2, if I plug in negative 2, what do I get? (16 minus 8). And then if I plug in 2, I get 16 minus 8, which is 8. So f of negative 2 is equal to f of 2. So Rolle's theorem applies. All right, so we're trying to see now, where does, in between negative 2 and 2, what value gives me a horizontal slope? So you're trying to see, where does f prime of x equal to 0? So what would your derivative be? Minus 4x. And you're trying to see, where does that equal 0? Right? So what can I take out? Okay, and I'm left with x squared minus 1. Okay, good. So that means that x could possibly be what? 0. Okay, good. Now, are all three of those on my interval? Yes, right? So I should have a horizontal slope at 0, 1, and negative 1. Right. So let's put that into put it into your calculator, see if we got it right. Right, so you should put in your original equation, x to the fourth minus 2x squared squared. Now, what do you want to change your window to? Negative 2 to 2. And then this should probably be like negative 10 and positive 10. Okay, so we figured out that we have horizontals at 0, 1, and negative 1. So negative 1, 0, and positive 1. All right? So again, if you have the same value twice, right, there's got to be at least one time where it kind of changes direction. In this case, it changes direction 3 times. All right? Yeah, so you're right. You got one here, here, and here. Yeah, I did it from -2 to 2, and then -10 to 10. All right, so you have horizontal tangents at those 3 points, and you could probably, we probably could have sketched that without having to graph it. Yep. Yeah, but the big thing is you have to make sure that the conditions work first. So you have to make sure that it's continuous and differentiable on your interval, and then you have to make sure that your endpoints give you the same value. Right, and solve. Right. Now, a lot of times this won't be the case, so you can't do it.